Good morning, sir.
Morning, sir. Hello, sir. Good morning.
Good morning, guys.
Good morning, sir.
Have we discussed this question? The direct online starter squirrel cage motor is used for electrical drive on AC powered ship. This question we have already done or not yet?
Not at
Okay.
Squirrel cage model we have discussed, no?
that is starter. That is, I think, first question. Coral cage, and this one is starter.
So you want to go for question first or you want to go for numerical first? Better numerical, right? Because numerical takes time. A DC motor take an armature current 1110 amps at 480 volt. The resistance of the armature circuit is 0.2 ohm. The machine has 6 pole and the armature is left connected with 864 connector. The flux per pole is 0.05 Weber. Calculate the speed and the gross torque developed by the armature. So first we will write what all things are given in this particular problem. So they have given the armature current, right? How much is the armature current? One ten, right? Voltage for 80. Armature resistance 0.2. Number of pole 6. Number of conductor 864. Then flux per pole 0.05. All these things are given in the problem. And what they want us to find out? They want us to find out speed and gross torque developed. Guys, written this much?
Yes, sir.
So what is the formula for back EMF? Anyone remember from yesterday?
P5L Z divided by 60 A.
Okay, and another formula?
P minus IARA.
P minus IARA. So what is what all things you are having here? You are having V, right? You are having I also, and you are having RA also. So can you calculate back EMF? Can you calculate back EMF using this formula?
Yes, sir.
Yes, sir.
So please calculate what will be the value. E equal to V minus IA into RA. Put all the given details. You know the V, you know the I, you know the RA. So what will be the value for E? Just tell me.
Four 58.
458. Your V is 480. Your I is 110. RA is 0.2. When you are going to solve this, you are going to get the value 458 volt. And what is the another formula for back EMF? What is the another formula for back EMF? You told just now, right?
P5 N Z divided by 60A.
E equal to
P5N Z divided by 60A.
divided by 60A. Very good. So now what all things you know here? Can you
P.
calculate N? And when they say lab connected, so value of A will be equal to number of poles. Okay. So number of poles are given in the question, that is P equal to 6.
Sir, can you repeat what you told us now?
If your motor is lab connected, can you see here? They have written your motor is lab connected. So when your motor is lab connected, the A value of A will be equal to number of pole or number of parallel path, that is equal to 6. So A and P will be equal to 6. So now you know everything in this particular formula. Can you calculate N? Can you calculate N?
Sir, last time for this wave winding A equal to 2. So in lap winding, is it like that? A equal to P?
Yeah, value of A is going to vary according to the given in the what is given in the solution. What is given in the
Always
question.
like that, only lap winding is always equal to A equal to PA.
Yeah. If they are saying it is lab connected, so it will be equal to number of path, and number of paths is equal to number of poles.
Sir, I think lap winding A is
Last
equal to P, and for wave winding A is equal to P divided by 2.
Yeah. So can we calculate N now? What will be the value of N? E equal to P into phi into N into G divided by 60A. Please calculate N now.
Sir, could you repeat this formula? E equal to P into what you written there?
I'll write again. E equal to P into phi. Phi, what is phi?
Flux.
Magnetic flux into N into G divided by 60A. So you know the P, you know the phi, you know the G, you know the A. Can you calculate N? You know the E also. Guys, are you calculating? If not, then I will tell you the value and then I will go ahead.
Sir, calculating. Sir, this
Yeah.
value of A is 6, no?
Yeah, value of A is 6.
And the value of phi is 0.05.
Value of phi is 0.05.
Answer 636.1.
636, right?
636.1.
Yeah. So RPM is 636. No need to write 0.1. You can round off to 636. Okay. Then the next first part is already clear. We already covered the first part. They are asking the
Sir, do you
RPM.
have the write-up? Okay. Sir, finally, could you show the write-up after finishing this problem?
Okay. So in the second part, what they are asking?
Torque.
Torque. So formula for gross torque for a electrical motor is (0.159) phi into G into IA into P divided by A.
Gross torque it is 0.1.
0.159.
5 into Z into
I'll write just it. This is the formula for gross torque. We are going to discuss this formula in detail. For the time being, you write down the formula. So what is gross torque? When we talk about electrical motor, gross torque means the total torque produced by the motor. This include both useful output that contribute the motor mechanical work as well as include the friction loss, winding loss, and other factor. So basically, gross torque is the measure of total twisting force generated by the motor armature. So how much total torque your armature is generating. That is known as the gross torque. And if you talk about DC motor, in the problem they are saying DC motor, for calculating the gross torque, your formula is 0.159 pi into G into I into P divided by A. Clear what is gross torque?
Yes, sir.
This is the formula for DC motor gross torque. Okay, so can you calculate now gross torque for this particular question? Can you calculate gross torque? Everything is given, right? 0.9195 is a constant. Phi is magnetic flux per pole. So already in the question, they are given the magnetic flux per pole. Sorry, 0.05. G is, what is G? What is G? Number of conductor, right? IA,
864.
yeah, IA is 110 and P and A is both are 6. Pole is given 6 and they are lap connected, so its value is 6. So can you calculate torque now? Just calculate and tell me the value.
755.
755. Okay,
0.56.
okay. I'll just post the solution so that you can copy and so you can refer to the solution before your exam again. Please note down this one, then I will erase and I'll post the second part of the question. Then guys,
Yes. So the second formula. um,
we're talking about this one.
No, sir. Previous slide. Back EMF problem.
Something wrong? No, no.
No, sir. I just thought you missed that P.
Okay. Gross torque formula is also here. Everything is here actually. Finish this much, then I will put the gross torque calculations also. Guys, finish. Still
Yes, sir.
writing.
Finish.
Okay, then we'll go ahead. So this is a question from your written last month. Direct online squirrel cage motor is used for the most electrical drive on AC power ship. Describe with the sketch and necessary one method of overcoming each of the following: high starting current and low starting torque. So what do you understand by the question? What is your understanding as per this question?
Squirrel cage motor, how, what is the method to reduce high starting current? And
So they are saying when they are direct online starter are using, there are problem like high starting current and low starting torque. How you can overcome this? Okay. High starting current to overcome the problem of high starting current in the spiral cage motor using the AC power ship, a common method is star delta. I hope all of us is aware of what is star delta. This star delta, starter, auto transformer, all the starters of starter we are going to discuss in the separate lecture. So for the time being, we are just seeing how we can overcome all this problem. This method reduces the starting current drawn by the motor during the initial startup, and let us describe this method with a sketch. So sketch, just wait. this sketch we are going to discuss what is happening when your motor is start connected and what is happening when your motor is delta connected. So can you tell me which side is star connected and which one is
B.
delta connected? Figure B
B.
is star connected and figure number A is delta connected. Squirrel cage motor connection. The squirrel motor is typically designed with the phase A, B, and C. Each phase consists of a stator winding connected to form star configuration. Star delta starting method. The star delta method involves two sets of the connection, one during the starting and other during the normal operation. During starting, the motor is connected to the star configuration, which means all three phases are connected to the common point. So can you see all the three phases are connected to the common point? This results in a reduced voltage across the each winding. So what you are doing, basically your voltage is getting reduced in each winding. How much reduce? So now you are reducing the voltage. The reduced voltage reduce the starting current of the motor. After the motor reaches a certain speed, attains sufficient torque, the connection switch to delta configuration. In delta configuration, the motor receives full voltage and continue to run with the normal operation, operating current and torque. So what we are doing basically when it is star connected, can you see the phase voltage is 1/√3 of line voltage, right? So basically V is equal to, what is Ohm's law? What is V is equal to?
IR.
IR. So you are reducing the voltage. So your starting current will also reduce, right? Second part is low starting torque. To overcome the problem of low starting torque in the squirrel cage motor, especially in the application where high torque is required, a soft starter can be used. A soft starter gradually increase the voltage supply to the motor during the startup. Which allow for a smoother and more controlled acceleration, resulting in the increased starting torque. So you can use the soft starter. The soft starter is a device inserted between the power supply and the motor, and it controls the voltage supply to the motor during the startup. It is also controlling the voltage when your motor is starting, limiting the starting current and providing a soft and controlled acceleration. What we are using in the soft starter, this we are going to discuss in detail when we are going to cover the theory. Tomorrow I'm thinking I'll keep the theory part where we are going to discuss about soft starter, all kind of starter and starting of generator, actually how your AVR is working. You should know all this basic, then only we can come to the question answer and you can be more interactive in the class. Like this, I think you don't have any idea about any of the starter, right?
Yes, sir.
So like this is very difficult if we are directly jumping on the question without making our basics strong. But we have the time constraint. If we are going to study the theory full, obviously, then you will not be able to cover the questions. So these are the two methods by which you can overcome the problems like high starting current and low starting torque. So the next question was, discuss the various hazard and the problem which is associated with the electrical cable insulation in the event of the fire. So they are saying if there is a fire, what are the various hazard associated with the insulation of the electrical cable? Then they are saying suggest the remedies. How the spread of fire may be reduced by the method used for installing the electrical cable. So how you can, during installation, what all things you should do so that spread of fire will not be there. hazard and problem associated with the electrical cable insulation in the event of the fire propagation. In the event of fire, the insulation material around the electrical cable can act as a fuel, right? And contribute to the rapid spread of fire. Once the insulation catch fire, it generates the additional heat and release the toxic acid. Second one is smoke and toxic gas emission. Burning cable insulation release thick smoke and toxic gases such as carbon monoxide, hydrogen chloride. These gases can be lethal to the occupant in the affected area and hindering the evacuation effort and possessing a significant health risk. Third one is short circuit and electrical failure. Fire damage insulation can cause the short circuit, arcing, or electrical failure. This can cause the power outage, disrupt emergency system, and create a hazardous condition for the firefighter and the rescue personnel. Melting and dripping. Some insulation material can melt and drip during the fire, potentially igniting other combustible material which is lying just below these electrical cables, right?
Yes, sir.
Damage to the firefighting efforts. Firefighter may encounter difficulty in controlling the fire when exposed to energized conductor with damage and compromised insulation. It increases the risk of electrical shock, right? That's why if there is fire on board the ship, what is the job of electrical officer? What is the job of the electrical officer in case of fire?
Switch off the power supply.
Switch off the power supply for the supply for the affected area, so that when you're firefighting are going inside with the charged water hose, and if your still electrical cables are energized, it might be possible they are going to get the electrical shock, right? So second part was they were asking remedies. So what are the remedies? Use fire resistance cable insulation. So you can improve the insulation of the cable. Fire barrier and fire stop. Installing fire barrier and fire stop at regular interval along the cable route and can help contain the fire within a localized area. How we are doing this? If suppose your cables are penetrating out of engine room, there are approved electrical putties, right? So that fire is not going to the another compartment, correct? Guys, we are having different kind of bulkhead on board the ship. Class A, class B, correct?
Yes, sir.
So suppose you have to pass electrical wire from the class A bulkhead. So can you just drill and pass?
This bland packing and all. It's needed.
Everything is there. So if you want to pass some new cable, you will pass only from the area they have designated before. And if you are removing any of the gland packing or electrical putty, you have to fix them back. Otherwise, this will become deficiency. Okay. Installing the fire barrier, fire stop at regular interval along the cable routes can help to contain the fire within the localized area and prevent its spread through the cable conduit or cable tray. Cable enclosure and fireproof coating and enclosing cable in the fire resistance ducts, or you can make special ducts. Obviously, this will not be cost effective. That's why we are not using these ducts and all on board the ship. Fire resistant additive, incorporating fire resistant additive into the insulation material. So obviously this is also a part of improving the insulation. Regular insulation inspection and maintenance. Regularly inspect the cable for the sign of damage, wear, degradation, promptly replacing the damaged insulation can prevent the potential fire hazard. So are we doing it? Are we checking our cables at the regular intervals? Yes, right?
Yes, sir.
And for the control circuit of especially for generator, we are changing this cable 5 yearly, correct? Rest all depend on company to company how they want to go about it, but some good company they are changing this cable 5 yearly, especially on the control circuits of the generators. So second part, they were asking how you can make sure the fire will not spread when you are installing the cable. So what should you do when you are installing the cable? Cable separation. Properly separate power cable from the data cable and signal cable to reduce the risk of electromagnetic interference and potential fire spread. So your data cables or signal cables which are passing through the cable trays along with the power cable, they should be separate. Fire resistance cable support. Use fire resistant cable support or hanger to hold the cable in place. This support can prevent cable from sagging and come in contact with the flammable material. Adequate cable tray and conduit. Install appropriate size of cable tray. It should not be like you put the small cable tray and then you are just piling up all the wire from the small cable tray. They are saying do not do the overcrowding. Flame resistance cable tie. So they are saying you can use the flame resistance cable tie also. Consider cable coating. Certain cable coating can provide additional fire resistance. Consider using cable with the special coating or jacket designed to withstand the fire hazard. So these all method you should keep in mind when you are installing, so that if there is any fire, it will not propagate from the electrical wires. The next question is, guys, you have taken screenshot of this question or you are writing? Guys, can you hear me?
I
So
took
take
screenshot.
Okay.
I don't know. Tony and all taken.
Okay, in case I'm moving to the next question without asking, then you can ask me to go back so that you can take screenshots. I will not ask same again. Okay. So next question is, what are the cause of overheating of the induction motor? So what do you think? What can be the cause? What can be the cause?
overload.
Overload how?
Some bearing damage or
Some bearing damage. Suppose this
anything.
motor is designed for low viscosity fluid and you're putting the high viscosity fluid, right? Motor are running the pumps. Basically, they are running pump on board the ship, right? Okay. So cause of
Pump
pump bearing damage, motor bearing damage. Instead of putting low viscosity fluid, you are putting high viscosity fluid. Obviously, there will be more pressure on the more load on the motor. You must have seen this on the transfer pump, right? When you are changing over the tanks. Correct or no? The amps increase. Suppose you are running purifier and your purifier is belt driven and belt is too tight and you started the purifier, the current will be very high, right? Yes or no? Your purifier brake is engaged and you started the motor. What will happen? Load will increase, correct?
Yes.
Okay. So cause of overheating of the induction motor, the first one is overload. Running the motor at load higher than the rated capacity can cause the overheating due to the increased current flow and increased loss in the motor winding. Second one is low voltage. Operating motor at low voltage than the rated voltage can increase current draw, and because V is equal to IR, reduce cooling and leading to overheating. High ambient temperature. Obviously, your motor will be having the more temperature. Inadequate cooling. How inadequate cooling? Your fins are
Dirty
dirty.
fins.
Dirty fins. What else? Motor fan is not proper, or you have just put something behind the fan, correct? You covered the motor with some plastic. Obviously, then cooling will not be proper. Insufficient ventilation, poor ventilation in the motor enclosure can prevent proper air circulation, leading to the heat buildup and overheating. Winding fault, short circuit, open circuit. If there is open circuit, what happens? We already discussed this thing. Guys, we already discussed, right? Single earth fault. Do you remember or no?
Open circuit, single phasing.
Single phasing we already discussed, right?
Yes, sir.
These all can cause the excessive heat in the motor. Preventive measure against the damage to induction motor is installed condition. So what all things you can make so that your motor will not damage? Proper installation, ensure the motor is correctly installed, aligned. Obviously, alignment is also a problem when you're aligning, especially with the horizontal pumps, right? If they are not properly aligned, the motor is going to get overload, right? Ambient temperature consideration. Install the motor in an environment with a suitable ambient temperature and ensure adequate ventilation for proper heat dissipation. Voltage regulation, maintain the motor operating voltage within specified range to prevent the overloading and overheating. Overload protection, install the overload protection such as thermal overload, electronic motor protection relay to protect the motor from the excessive current draw. So you can put the overload protection which can measure the, so what all protection we are using on the motor? We already discussed, right?
Overload, overload protection.
What all protection? What all the things are we are using? Fuse, right? Bimetallic strip, relays, right?
Overcurrent protection.
Phase imbalance protection. Implement phase imbalance protection to prevent the damage due to the unbalanced current. Regular maintenance, perform routine maintenance, including the cleaning, lubrication, inspection to identify, address potential issue before they lead to the motor damage.
Sir, phase imbalance protection.
We are not using this normally, but obviously you can write if some phase is taking less voltage or some phase is taking more voltage, you can put n number of protection. It only depend how much money you want to spend.
Okay.
Purpose of fuse backup protection in the induction motor. So this is your third part. What is the purpose of fuse backup protection provided in the induction motor? The fuse backup protection is an additional protective measure provided on the induction motor. The purpose of this protection is to safeguard the motor from the severe damage in case of the failure or malfunction of other protective device. So this is your last protection. Fuse is your last protection. Suppose your overload relay is not working, your bimetallic strip is not working, everything is not working, then this fuse will come into the picture. That's why they are saying fuse backup protection. They are saying it's as a backup. So don't get confused between fuse and fuse backup. Okay, they're talking the same thing. So what they are saying, failure or malfunction of other protective device such as circuit breaker, motor protection relay. If this primary protective device failed to interrupt the circuit during a fault condition, the fuse backup protection will act as a last line of defense. So our fuse is last line of defense, blowing the fuse and disconnect the motor from the power supply. So have you came across any situation till now where your fuse are gone for the motor? No, right? Why? Because these are the last line of protection. If something is wrong, your relay and your circuit breaker are going to trip. If they are not tripping, then your fuse is going to melt or blow. The next part is, how does an induction motor develop torque? An induction motor develops torque through the interaction of the starter rotating magnetic field and rotor conductor. Starter rotating magnetic field, when there are three-phase AC power is supplied to the starter winding, it creates a rotating magnetic field due to the phase difference between the current in the winding. The rotating magnetic field rotates at synchronous speed, that is Ns, based on the frequency of the supplied AC power supply and number of pole in the motor. Rotor reaction, the rotor magnetic field induced voltage in the rotor conductor. The rotating magnetic field because of what? Stator, right? Induce the voltage in the rotor conductor, which in turn create a rotor current. This current interact with the stator magnetic field and producing a force on the rotor conductor known as magnetic drag. So the direction of the rotor, you are going to, if you want to know the direction of the rotor rotation, how you will know? Fleming, which rule? Which hand?
Right
Right
rule.
hand.
Right hand or left hand?
Motor left hand rule.
Left hand rule. So you have the magnetic field here, you know the current direction, so you can know the direction of the motor, right? Torque generation, the interaction between the stator magnetic field and the rotating magnetic drag force cause the rotor to start rotating in the same direction as the stator magnetic field. This rotation of the rotor produces a mechanical torque which drive the connected load to the motor. Condition for achieving maximum running torque in an induction motor. So this is your last part of this question. What is the condition to be satisfied for achieving the maximum running torque? The maximum running torque in an induction motor is achieved when the rotor is relative speed is equal to the synchronous speed. So when your motor is running equal to the synchronous speed of the stator rotating magnetic field, then it will generate the maximum torque. So how you calculate the synchronous speed? Ns equal to 120 into F by P. This is the formula we are studying from our 12th standard, right? I hope everybody is aware of this formula. So where Ns is synchronous speed in revolution per minute RPM, F is the frequency in hertz, and P is the number of pole. So your slip is defined as Ns minus Nr divided by Ns. What is the Ns? Actual rotor speed. So sorry, Nr. Nr is actual rotor speed. So for developing maximum torque, slip should be actually 0. The condition implies that the rotor is rotating at a speed equal to 0 relative to the stator rotating magnetic field, which only achieve when your motor is initially starting up. Once the motor reaches the operating speed, the slip decrease and the motor operate with the lower running torque. Clear, guys? That's all for today. In the next class, we are going to have some literature so that you know some basics, and then we are going to go on the question again from the next class. So tomorrow, that is Friday, we are going to discuss about theory. Then Saturday again, we will discuss numerical and question answer. I have to develop the theory side by side. Okay.
Okay.
I
Okay,
hope lecture was useful to you.
Yes, sir.
Okay, guys.
Yes.
Then see you in the next class.
Okay, sir.